Assalamualaikum warahmatullahi wabarakatuh to Dr. Shaharil bin Muhammad Shah. We are from Group 8, Section 3. Our group member is Nurul Haziqah Binti Zaifuddin, Tuan Nurul Afiqah Binti Tuan Putera, Nadia Binti Zakaria and Nadzirah Binti Muhammad Zawawi. For this ECS project, the chosen title is AM Radio Broadcasting Application using Amplitude Modulation Technique. For the introduction, analog modulation is the process of transferring an analog baseband signal audio over a higher frequency signal such as radio frequency band. In radio communication, modulation means combining signal which needed to be transmitted with radio frequency signal or the carrier. There are two ways to modulate an RF carrier, which are by amplitude modulation and angle modulation. An AM radio broadcast is one of the systems that use amplitude modulated technique for its transmission system. It typically having a medium frequency of 300 kHz to 3 MHz. AM radio having some advantage over FM radio, such as its use of narrow channel bandwidth and wider coverage area. So this paper presents a design of an amplitude modulation, transmitter and receiver circuit of an AM radio broadcast. Software used is MATLAB Simulink to perform the modulation and demodulation of AM radio broadcast consisting of information source, transmitter, medium, low pass filter and receiver, where the time and frequency domain signal is analyzed.
My name is Nadzirah Binti Muhammad Zawawi and I will present about the methodology of this project. So this is the simulation of radio broadcasting using amplitude modulation. The system is designed using MATLAB Simulink. The system was designed to analyze the signal to vary the amplitude of the carrier sine wave in according with the amplitude of the message signal. It consists of message signal, carrier signal, transmitter, receiver, and low-pass filter, which is LPS. And this is the scope that used to generate the waveform of the system. The waveform produced is the message signal, carrier signal, AM signal, receiver signal, and recover signal. And this is the spectrum analyzer that will produce the modulated signal in frequency domain. Okay, next, this is the block diagram of the project. The information signal is connected with transmitter, which to transform the electric power. Okay, the carrier signal is create the carrier signal create the wave which carry the information through the air from transmitter to receiver to transmit the information space as an electromagnetic wave as in radio communication. And then the receiver will connect with the low pass filter, where the low pass filter is the one that only allow high frequency to pass through while at the same time and attenuating every signal frequency. After the high frequency signal are filtered, the resulting signal frequency gets smooth and clear quality.
Okay, hi, my name is Tuan Afiqah Binti Tuan Putera. So I'm going to present the simulation that we have conduct using MATLAB Simulink. So this is the diagram that have been built in the MATLAB Simulink. So we have here is message signal generator, the carrier, and the product block, which represent the transmitter and also the receiver modulator. And this is the low pass filter, where we have used two block. And then this is the scope where we need to analyze the wave or the signal from the message carrier, from the AM modulator, and also from the low pass filter. So the message signal generator has been set to the amplitude of 5 and the frequency of 3000 Hz. Okay, and the carrier has been set to the amplitude of 10 with the frequency of 300,000 Hz. Okay, then this is the low pass filter, and then we will run the this simulation at stop time 0.001 second. So let's see the outcome. Okay, so this is the message signal, waveform of message signal, carrier signal, transmitter signal, receiver modulator signal, and recover signal. So based on the 5 message signals at 5 volt, we can see that we have recovered the signal at 3.8383 volt, where we can see that based on both waveform, message signal and recover signal, there is only slight difference between it. So this is the carrier signal, and this is the AM modulate signal from the message and the carrier signal, the product of the message and the carrier signal, and then this is the modulated one, and this is the recover signal. Okay, now I will present about the frequency domain, the amplitude modulating signal by using a frequency domain. Okay, as for the frequency domain analysis, we have built this circuit based on the main circuit for AM modulating signal. So we have set the constant at 0.5. The message is set have been set the sample time to 0.0000005. Okay, and the carrier and the sample time for the carrier has been set to the same value, which is 0.0000005 second. So the outcome is being analyzed from the spectrum analyzer. So this is the waveform. We can see that at this point, this is the frequency of upper and lower sideband, and also this is the carrier frequency, and this one is the upper sideband frequency, where we have get 0.303 megahertz, and the FLSB is 0.297 megahertz.
Hi, my name is Nadia. I'm going to present to you our group project result and discussion. So first, the waveform signals are simulated using MATLAB, and the value for VM, VC, FM and FC are set as in the table. For VM, the voltage is set as 5, and for VC, the voltage is set as 10, and for the FM, is set to 3 kHz, and for the frequency carrier is set to 300. And for the modulation index is 0.5, which is below 1. Next, let's proceed with message and carrier signal. As can be observed in this two figure, the message signal peak amplitude is 5 volt, and for the carrier frequency waveform pattern is set to 300 kHz frequency. And before transmit the signal from the transmitter to the receiver, this message signal we combine with carrier signal, where the purpose of the carrier is to transmit the information through space as an electromagnetic wave. Next, let's proceed with AM signal and receiver signal. For the AM modulated signal waveform pattern is the combination of message signal and also carrier signal, where it is being modulated. The peak amplitude of this AM modulated signal is 4.329 volt. The signal is then being transmitted to the receiver signal as shown in the figure on the left, which is receiver signal. And at the receiver modulation signal, process of demodulation is involved, which detecting the envelope of AM signal. the peak amplitude of this signal is 3.749, and in this process, it will remove the oscillating carrier signal, which leaving only varying amplitude. For AM transmission, it is limited by restraint to keep the modulation index lower than unity. Next, let's proceed with recover signal. Recover signal is produced after the demodulation. The peak-to-peak value of the recover signal is 4.965 volt, as shown in this figure.
As for the conclusion, this project has finally achieved the main goal, which is to design the amplitude modulation communication system for radio broadcasting by using MATLAB Simulink. This project has analyzed the characteristic of the waveform based on the information signal, transmitter, medium and also receiver. The outcome from the AM modulating signal can be represented by the mathematical equation, while the outcome from the frequency domain analysis has identified that the upper sideband frequency is at 0.303 MHz, while the lower sideband frequency is at 0.209 MHz. Overall, this project managed to analyze the time and frequency domain signal for each block diagram using MATLAB Simulink. Thank you.